Hello, I'm Jay Gandhi. I'm presenting Lab 4 of Physics 2. So the purpose of this lab was to measure the distance dependency of the magnetic field due to the small bar magnet. So models and physics principles, I use a GlowScript computational model, and then I use the Bott-Schubert equation. I think I mispronounced it. Um, Brief preview. So the exponent that I calculated was negative 3.11 that which is pretty close to negative 3. And then the magnetic moment was equal to 3.59. So physics principles, this is the B field equation that we used, where R is the distance vector from the magnet. And then the magnetic dipole moment points from the south to the north pole, and it's given by mu. So reasoning and system and surroundings. So for graphing purposes, we linearize the equation given by this formula. K is going to help us get the magnetic moment for the GlowScript model. And then initial assumptions, we can assume that when the distance increases, the B field decreases. So that's how we check that our results are kind of right. And we'll justify this later on. So the system is just a bar magnet, and the surrounding is going to be the Earth's magnetic field and other electronic items that produce a magnetic field. So experiment explained. Rotate the phone until the Earth's field is orthogonal to the phone, and then find the magnometer chip in the phone, and then take distance measurements for the certain B field. All right, so here's my data. Um, yeah, so as you can see, like the closer you are to the bar magnet, the higher the B field is going to be. So closer you are, the higher the B field. And then by linearizing it, we can see that the exponent is negative 3 based on the slope of the equation. And then this is going to be plus ln of k. And then we can solve that for our magnetic moment. So here's my code. Yep, so the magnetic moment that we calculated was inputted into GlowScript, and then I made a function for the dipole moment, or the B field. So, and then I made perpendicular arrows given by the blue arrows, the teal ones. These are off-axis arrows, and then the orange ones are going to be parallel to the axis, and then the purple one is going to be 45 degrees off the axis. All right, similarities. So my observations were when the magnometer is far away from the magnet, it measures a near zero magnetic field in the x direction. As the magnometer moves closer to the magnet, the measured x component of the magnetic field increases. Sources of error. So other electronic items cause another magnetic field that affects the reading. This is different from the model where the only magnetic field source is a magnet. Yeah. So the observations were similar to the model as well. What if questions? So if the phone was not orthogonal to Earth's field, then the reading in the x component direction at the same distances would show an increase because the Earth's field is going to add to the existing field. If two magnetic bars were brought together end to end, the magnetic moment doubles. So at the same distances, the magnetic field would be greater, and you can check this with the formulas given on the formula sheet. That was my presentation. Hope you enjoyed.